Great, my wonderful students. I welcome you once again to our lesson today. So today we are looking at one of the important aspects of the senior high school additional mathematics. Yes. So this is going to be on the concept of trigonometric functions and their applications. But our lesson for today is going to be limited to only the trigonometric functions, that is the ratio. All right. Yes, but before that, my name is Evans. I'm still your mathematics facilitator. This is Maths TV. Can you subscribe, like, and share? You can also follow me on Facebook and TikTok. All right. So, as I said, that we are going to look at the concept of trigonometric functions. So, my dear students, I want you to pay attention. All right. Gather your stationaries. You get your book or your paper, so that you can put down some important information. All right. Yeah. So, without wasting my time, let's quickly look at what we have today. All right, yes. So for trigonometric functions, this one deals with, or it is related to the right-angled triangle and its what sides. All right, yes, that is what we are going to look at. So we have three basic trigonometric functions. All right, and these are the sine, which in short we call what sine, as in sin. And then we also have what cosine, as we also shorten as what cos, and then we have tangent. Then after the basic three, okay, we have these three, we have their reciprocals. So it is from these three basic three ratios, or these trigonometric functions, that we get their reciprocals. So if you take sine, what is its reciprocal? Then we have what the cosecant. Cosecant. In short, we say what cosec. Yes, and then if you take cosine, its reciprocal is also what secant, and we also shorten as what sec. And then we also talk about tangent, which has its reciprocal as what cotangent, also called what cot. Yeah, so in all we have six what trigonometric functions. So we are going to find out, we are going to look at how we'll be able to find values, whether positive or negative, in a Cartesian plane, or how we are going to form a right angled triangle in the Cartesian plane and find the ratio of their length of a given what angle. Yeah, so I will not waste my time, as we are seeing that all these functions can be used to find the ratio of the side length of a right angled what triangle. So let's quickly look at what we are talking about. So let's take our Cartesian plane. Okay, so we have our x and y axis, which divides the Cartesian plane into what four parts. Okay, four parts, and these parts we can name them what quadrants. Okay, we name them what quadrant. So we can have what the first quadrant. Okay, the first quadrant. Then we also look at the second quadrant. So for the first quadrant, you realize that the x-axis, the y-axis, all those values there are all what positive. That's why you see plus x plus y. If you go to the second quadrant, you yourself can attest to that. You realize that we have what the x values being what negative. So the x-axis part is negative and the y is what positive. Then let's come to the third quadrant. In that quadrant too, we are saying that both the x and the y axis are what negative. Then the last quadrant, which is the fourth, also we have what the y being negative and the x positive. So if I give you a point or coordinate for you to um plot on the Cartesian plane, you should be able to tell me where, in which quadrant are you going to plot it. Yes, so these ones are very what basic. All right, now let's move on. Okay, so let's give example. For instance, if we have this example, how are we going to um plot them in the Cartesian plane? All right, so in plotting them, I mean how you are going to form the right angled triangle. All right, so let's see. Okay, so if we have this, then first one, our first is what? P. We have point P, which gives what? -3 and 4. So you realize that the x value is negative, the y value is what? Positive. In that case, which quadrant? The second quadrant. So that is where we draw our right angle. Now, this line drawn here is what we term as what? The terminal side, okay, of the right angle triangle. That is the terminal side. Okay, yes. So that is in the second quadrant. Now let's look at the Q. Okay, so you realize that they are all positive. If they are all positive, then definitely they are also what? We can also get the right angle triangle uh, in the first quadrant. Yes, and then we are good to go. Now let's look at the R, which says they also have what? -5, -7, then automatically the third quadrant, we are going to get the right angle triangle there. Then the last one, which is the S, Y is negative and then X is positive. So in the fourth quadrant, yes, so that when we give you such examples, you will know where to get your right angled triangle. All right, yes. So let's continue. Okay, yes. So let's take this. We are saying that giving a theta an angle in standard position, the terminal side R and point P, which gives what? X and Y on the terminal side of the angle, we could form right-angled triangle in Cartesian plane and determine the signs of the trigonometric functions of angles. Yes, so this one, we are going to use the Cartesian plane and also form what? A right angle triangle, and look at or determine the signs. Okay, yes, either whether we are going to get, if we find the maybe sine theta, um, whatever quadrant that it will fall, whether we are going to get a negative figure or we are going to get um, positive figure. That is what we are going to do now. All right. Yes. So if that's the case, then let's take our Cartesian plane again. We draw our two axes. Okay. Then we are going to use what we call what? The cast, or another term that we use. For you to remember, you can use the cast, or all students take calculus. Yes, this is a popular um, method or a popular citation that you can uh, recite. You can use in case you forget. So let's dive into what we mean by the cast and why the cast, or all students take what? Calculus. So for the cast, now if you see C, okay, yes, so we see that we have the first, second, and the third. All these are what? The quadrant I'm talking about. Okay, yes. So if you take the cast, then it means that we are going to put each letter in a quadrant. So we see where each of the letters are. So if you see C, what does the C mean? The C means that we are talking about cos. You know that for the trigonometric functions, we have cosine, we have sine, tangent. So the C stands for what? Um, Cosine. If you see T, what does the T? Tangent. What about S? S is what? Sine. Then what about A? So someone may be arguing, if we know all this, then what about A? So A, for the meantime, we say what it stands for, what? Or, A-L-L, or. So we'll explain that why we are saying or. Okay. And then we can also use the all student take what? Calculus. So let me also distribute and see where each of the words will go. So you see the or, the A stand for what? The or, and then the C, I'm using what? Calculus in place of the C, and I'm using take in place of what? T, then I'm using students. So in case you forget the cast, you can also use what? All students take what? Calculus. That is also one of the fastest way you can learn to remember this. Okay, so why the cast and why all students take calculus? So you know that we are saying that the Cartesian theory we have what? We are saying the y and x axis. Yes, so we are saying the x and the y axis. Okay, divide the Cartesian plane into what? Quadrant. So the A, which is what does it mean? So what we are saying is that if you see in the first quadrant, whatever trig function you find there, it means that that function is positive. So we have how many functions? We have what? 6. Apparently, we have 3 basic or trigonometric functions, and then their reciprocals added, making what? 6. So it means that in that first quadrant, all these 6 what? Um, trigonometric functions are positive. That means we will get what? A positive value there. That is what we are talking about. All right. If you go to the second quadrant, why we are putting S there? So the S there also suggests that, or why we are putting students there, it also suggests that in the second quadrant, what does the S stand for? The S stand for what? Sine. So if sine is there, it means that all the um, 5 ratios or functions are negative except the sign. Yes, so the sign, we will say that it is each home. Okay, each home is in the second quadrant. So sign is positive. The rest of the functions are what? Negative. And if you go to the third quadrant, T is there. So automatically T is also playing home. So it is T's home. So T is positive. The rest of the functions are what? Negative. Now, when we choose, we talk about they are being what? Home, meaning they are positive. Their reciprocal is also positive. If it is negative, its reciprocal is also negative. If it is positive, its reciprocal is also what? Positive. Yes, as simple as that. All right. Then in the quadrant 4, we are seeing that C is there. So automatically, you can conclude that cos is also what? Positive over there. The rest are all negative. So cos and its reciprocal, they are positive. All right. So let's see. Okay. So you see that all this one, you see, for the first quadrant, all of them plus, 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 meaning that they are all positive. Now, if you go to the second quadrant, you realize that it is only the sign and its what? Reciprocal, which is positive. The rest are all negative. You go to the third quadrant, it's also only the tan and its what? Reciprocal that are what? Positive. And then the fourth quadrant, you see only the cos and its reciprocal is positive. So that is what we are talking about. My dear students, if you see this one is not just there for nothing. All right, it means so once putting all this, all students take calculus or you are using the CAS, that is what it means. Okay, it's just there to help you remember so that if you get the question and you are drawing your right angle in any of the quadrants, then you know what to do. Okay, yes. So if that is the case, then um let's say we have our coordinate and then we have what? The point x and y. Okay, so that is what we are talking about. Now this line from the center O to P is what we call what? The terminal side. It's going to be the terminal side, and it's also what? That is the R. Okay, so the R is the terminal side of the um right angled triangle. Okay, and it also represent the distance of what? The distance from the origin O to P. That is the terminal side. Then we form the right angled triangle. So once we form there, then you see that the vertical parts represent what? The y axis, and the horizontal part as on the x-axis also represent what? X. Then the angle between the terminal side and the initial side. Then the initial side is the line on the x-axis. That's the initial side. So the angle between there is what we call angle what? Theta. And it is also an acute angle. Yes, why an acute angle? Because if you take every quadrant in there is what? 90 degrees. So if you are taking angles from there, unless maybe in that quadrant, the initial position is coming from another quadrant, then you can say that maybe that angle you are not getting what acute. But if you look at this one, this is an acute angle. All right, great. If that is the case, then we can what use, and remember also what we call what the SOHCAHTOA. Yes, the SOHCAHTOA. That is where we are using what the sine, cosine, and tangent. Okay, so let's find sine theta. So these are the trigonometric what functions. So we are going to find the value of what sine theta. If you are finding sine theta, then you look at the SOHCAHTOA. That means the O stand for what? Opposite, and H stand for what? Hypotenuse. All right, so it means that sine theta gives what? A ratio of opposite on the hypotenuse. Okay, then let's identify, yes, that is the SO, because it is sine. Okay, so we are using the SO. If that's the case, as we are saying, that is opposite over hypotenuse. So which side is our opposite? Now you realize that the side which is directly opposite what the acute angle, that side is what we call the opposite. Okay, if the angle would have been here, then the opposite will not be y, but it would have been what? X. So take note, wherever the acute angle is, the side that is directly what? Opposite, which is facing that side, is what we call the opposite. So it's not always that when the angle is at that side, then it means that the y is still what? Opposite. We can turn the diagram sometimes. All right, yes, that is it. So but because we are dealing with the angle formed on the x-axis, then we conclude that our opposite is what? The y. Okay, yes, if that's the case, then sine theta, since it is what? Opposite over hypotenuse, and we know that that length and the terminal side represent what? The hypotenuse, that is the r. So sine theta gives us what? Y on r. Let's look at it reciprocal, because we are seeing that since it is reciprocal, you just have to interchange x and y and r, because when you are reciprocating any fraction or any number, the denominator will come up and the numerator will go down. And we know that the reciprocal of sine is what? Cosec. So if that's the case, then you just interchange it. And note also that cosec is equal to what? 1 on what? Sine. That is cosec. So in case we ask you to find cosec and you know this, you can do it this way. All right. Then let's also look at cos. So for cos 2, we are using what? Ca. That is CAH. And it is adjacent on what? Hypotenuse. Okay, so if that's what we are also saying, that then adjacent, which part is our adjacent? That is the x. Okay, and as we know, for hypotenuse, that is the r, that is the terminal side. Okay, so if we find that one, then we can see that cos theta is equal to what? X on r. Then it reciprocal, which is what? Sec. Okay, or so we just reciprocate, we just what? Bring the numerator down and the denominator up. That is all. And note also that cosec theta is equal to what? 1 on cos theta. So take note of this one. That is the reciprocal. Then let's look at tan. Tan to, we are saying what? We are using TOA. Okay, that is TOA, which suggests that tan theta is the opposite on adjacent. So if tan theta is opposite, we know our opposite as y and adjacent as what? X. So we just substitute, and then we get tan theta as y on x. Then its reciprocal, which is what? The cot. Okay, is, you just, as I said, you just reciprocate it. So for when you are able to find the three basic ratio, finding their reciprocal is very, very easy. You only have to reciprocate it. Okay, and you are good to go. Note also that cos theta is the same as what? 1 on tan theta. All right, yes. So if we know all these things, then this thing was on what? The first quadrant. Let's see if they are on a different quadrant. Okay, if you move to a different quadrant like this, how will be the how are you going to write all these things? Okay, so first of all, now we're in the first quadrant, but this time we are in the second quadrant. So which of the ratios is positive? Think about that one. Okay, All right. Good. So in that quadrant, we know that the sign is positive. This suggests that everything, the sign and each reciprocal will be positive. Then the rest will be negative. So if that's the case, then since we've already done this, we just what choose those that are what negative and those that are what positive. So we see that sine and its reciprocal, they are all positive. What about cos? Because cos is not in that quadrant, so apparently cos will be what negative and its reciprocal. What about tan? Tan the same. It is also going to be what negative. So have you gotten the concept now? Yes. So once it is not in your home, then it's going to be negative. So that is how it is done. Now let's see if the right angle is in the third quadrant. Okay. Yes, if it is in the third quadrant, then which of them is playing home? Then automatically we see what tan. So it means that everything about tan is going to be positive. The rest are going to be negative. So in that case, sine and its reciprocal, cos and its reciprocal, they are all going to be negative except what? Tan and its reciprocal. So this one is very basic. The same applies to the quadrant 4. That one too, cos is playing home. So if cos is playing home, so we are taking it as like football match. If you are playing home, then that means you have power. Yes, so cos this time is playing home. For that matter, cos and its reciprocal will also be what positive. Then the rest will all be negative. That is what we are talking about. Very, very interesting. All right, so you realize that this concept is very, very easy. It's not difficult. If that's the case, then let's try and see if we can take one example, okay, and look at how they are going to, so that if you meet them in exams, you know how to go about them. So in this question, we are saying that the terminal side of angle theta passing through the point Q with the coordinates -6, -8. We have to find the values of the 6 trigonometric functions of angle theta. Also find the angle theta and then solve for square root of 2 minus tan theta all divided by cot theta plus sec theta. All right. So if that's what we have, then I guess we draw our Cartesian plane. So please, my dear student, I entreat that whenever you get questions like this, make good use of what the Cartesian plane. Draw your right angle triangle so that it guides you. Okay, sometimes we award marks for that. So it's very, very important. Questions like this, you bring diagrams. If that's the case, then let's start with our solution. So we draw our two line of what axis, that is the x and y axis, and the yes, so they divide the Cartesian into 4 quadrants. Okay, yes. So if that's the case, then looking at that figure, we have what? So our center is O. We have -6 and -8. So we've done this initially. We said that the sign there, if it is negative, you know where it is going. If x is negative, know which quadrant it is going. So this one, you realize that both the x and the y, they are all negative. Then which quadrant are we going to draw our right angle? Since in the third quadrant, both x and y are negative, then our right angle triangle will be there. So we draw our terminal side, okay, which is R, and then we join it to form the right angle. Then that is our point, okay, which also gives what? The x as that is the horizontal part and the vertical part. So we know that the vertical part is 8 and the horizontal part is for 6. Even though in the point we are giving -6, -8, the negative there is telling you which of the quadrant, which direction is it moving. Okay, yes. So it is only telling you that. Yes, good. So if that's the case, then let's proceed and find the 6 trigonometric functions. So we start with what? So by Pythagoras theorem, but know that before we be able to do that, we need to know the value for R. Okay, the value for the terminal side. Okay, yes. Yes, so since we know two sides, but we don't know the terminal side, that is R, then we need to calculate that one too. But how do we do it? That is by Pythagoras. Okay, we solve it. And what does the Pythagoras say? It says that um, the square of the longest side of the right angle triangle is equal to what? The sum of squares of the two other sides. All right, good. So if that's the case, then by Pythagoras, our R squared is equal to a squared plus 6 squared. And then we work things out, okay, and we get our final answer as what 10 unit for the terminal side. So the terminal side is what 10. All right, great. Once we have that, then we can proceed to find the 6 ratio. So we start with tan theta because tan is playing home. That's why I'm starting from tan. Okay, so we know that tan theta, that is 4, okay, opposite over what? Hypotenuse. So we know that our opposite is 8, and then yes, 4 is opposite over what? Adjacent, not hypotenuse, sorry. So we know that our opposite is 8, our adjacent is what? 6. So 8 divided by 6, and then we are going to we get what? The simplest form to be what? 4 divided by 3. But you ask yourself, because it is in the third quadrant, and in the third quadrant it is tan, which is playing home, then as we said, that is supposed to be positive. That's why it's positive. Then what will be its reciprocal? The reciprocal is just a matter of what? Interchanging the numerator and the denominator. So its reciprocal, which is the cotangent or the cot, is what? 3 on 4. Then we look at sine. Sine 2, we are saying that sine is what? So opposite over hypotenuse. So we know that opposite is 8 and hypotenuse is 10. But why are we negating? Yes, this explains why the cast is very, very what? Important. Because sine is negative, as I said, that we are not playing at the home of what sine, we are playing at the home of tangent. So apart from tangent, the rest of the trigonometric functions, all of them are going to be what? Negative. That's why sine is also what? Negative. And its reciprocal, which is what? Cosec, is also going to be negative. But in this time, we'll reciprocate it. Have you gotten that? Yes, very, very interesting. All right, then let's find the cos. Cos is also negative, as I said, but cos is for using what? That is what? Adjacent over what? Hypotenuse. Adjacent is what? 6, and hypotenuse is what? 10. So 6 divided by 10, then we find the simplest form. And must be negated because in that quadrant, it is not cos. All right, then its reciprocal, which is sec, okay, second, is also negative 5 on 3. We have reciprocated, as I said. Have you gotten that? So it's very, very interesting. So once we are able to go through all this one, then let's go to the other part of the question. So in question B, we are to find angle theta. So since we are playing in the home of what? Tangent. Then let's use tangent. Okay, so we said that tan theta is equal to what? 4 on 3. So finding the angle is very, very easy. All that you do is what? You take what? Arctangent of what? Both sides. So if you take arctangent, then it's going to be what? Theta is equal to tan inverse or arctangent of 4 on 3. Use your calculator and you are getting what? 53.13 degrees. Yes, because there's an angle. So don't forget to add the degree. Okay. Yes, so that is very, very interesting. If that's the case, then let's move on to the last part, which is the C. So we are to um find the value of this. So for this one, very easy. All that you do is after you are done finding the values of tan, theta, cot theta, sec theta, then you just substitute the values. And we've done all these things. We know that cot theta is 3 on 4 and sec theta is negative 5 on 3. So, and we also know that tan is what? 4 on 3. So we just substitute our values. Okay, so when you substitute your values, this is what you have. You proceed and then you work things out. Then you get your final answer. Okay, yes, and that's going to give you what? this as our answer. All right. Yeah, so we get our answer as what? 60 minus 12 root 2 all divided by 11. And we can write it in this form, which is going to be 16 divided by 11. Okay, yeah, 16 divided by 11 minus 12 root 2 divided by what? 11. So you see that's very, very easy. If that's the case, then let's end here and continue next time. My name is Evans. I'm your mathematics facilitator. This is Mathsbase TV. Don't forget to subscribe, like, and share. So see you next time. Bye bye.